Okay, so since we understand soil health, so we're not going to talk about the definition of soil health. We understand that it's important. To me, soil health just comes down to balance. How do we put in nutrients that we actually need and utilize them to produce bushels? How do we produce the optimum amount of bushels per acre or even less than an acre? How do I balance my carbon and nitrogen? How do I balance my fungus and bacteria? How do I balance my calcium and magnesium? Lots of other things as well. So to me, it's just coming down and finding that right balance. It's optimizing, balancing and optimizing not only nutrients in the field, the biology, but optimizing your bottom line as well as a farmer, and optimizing our yields to do that. So we're not going to talk about the benefits either. I mean, we understand there's a lot of benefits to soil health. You guys all know it. We're not going to spend time. So it's not to talk about soil health. So what are we going to talk about? So we're not going to talk about the benefits and stuff. Buzz through that. We understand. So I'll go into what we've been learning so far and how we can all work together, how we can leave this conference and make this stuff happen. So a little bit about what we've learned so far. So we've been studying and documenting. Did that just move on its own? We've been studying and documenting the ability to improve soil health. I've been doing a lot of the Haney Soil Health Test. We did over 1,000 Haney tests this year. And how we're utilizing that test, we're taking samples multiple times throughout the year to analyze changes in nutrient availability, in soil biology, in carbon, nitrogen. They change a lot throughout the year. And we need an understanding of how those nutrients change, how those nutrients come available. We understand when our crops use nutrients, especially thinking on corn. We understand when corn uses nitrogen. We're utilizing soil samples to analyze nutrient availability and working to align that nutrient availability with crop uptake. So we have too much nutrients out there, we're losing it to the water, we're causing issues. But if we don't have enough, then our corn is having a bad day. We have to make sure that we have the optimal amounts. So we're taking continuous testing, a lot of like side-by-side trials. All my stuff is farmer trials. I'm an independent consultant, so this is all my work directly with them and stuff I'm doing on my own farm. 2018, we'll be ramping up and doing a heck of a lot more testing too, so we're really just getting started. Taking a lot of video and pictures and stuff as well, so we'll get into that. My main objectives with analyzing soil health, I think we're missing two pieces. We're missing how do I logistically do it on my farm? Okay, so what cover crops work for me? That's good. We have the soil mix tool that we had a presentation on today. Okay, that can help. When do I plant that cover crop? At what rates do I want to do it at? There's a lot of questions. How do I set up my equipment? What's going to work for me? And the answer that we hear from our neighbors all the time, well, my soils are different, or my climate is different, or whatever. Well, what can work for you? There's tools that will work on those farms. They plant cover crops in Canada. I mean, we can make it work here. We just need to help logistically figure that out. And it takes learning from each other. So that's what we're working on doing together. The economics have to go along with this. And we're struggling right now. We had a presentation on the economics of cover crops, and the results were kind of depressing. But there are people who are getting positive economic benefit from cover crops. So we need to be able to learn from those guys. We need to be able to share and analyze the economics of soil health. By utilizing soil testing, we're trying to optimize nutrient utilization, so saving us some money on the front end, return a better yield on the back end. That's a double whammy on getting the economics to work out. We also need to adjust those economics, adjust those inputs for each area of our field as well, down to a very small amount of land, and optimizing our inputs for each very small piece of land, even less than an acre. Okay, so here's a little bit about like what we're doing. Here's what it looks like. At each of these dates, okay, so I've been pulling soil samples with the Haney Soil Health Test every 15 days. And I've got stuff going all year round, every 15 days. This is just the bulk of what we did in 2017. This is Southeast Iowa only. At each date, You'll see it's April 1st, April 15th, May 1st. At each of those days, there's about 100 samples each. This is no-till versus tillage. There is more of my data set. There's more in the no-till versus tilled. Why I showed this graph is we're looking at changes throughout time. The green and red lines on top is soil activity, biological activity. So with a Solvita test, we're able to collect soil in a jar, wet it, and collect the CO2 that is emitted from that soil. So microbes are breathing just like we are. So if we were to cap off this room, and with a lot of people in here, we're going to emit off CO2, we can collect that. The more people we put in here, the more CO2 emitted. It would also work the same if we all were to run around and breathe heavy. We would we would increase the level of CO2 as well if we were all very active. Soils do the same thing, okay? So that's what this data is that we're showing. So we want good biology. I think to me, that's the number one piece on soil health is the thing that's alive, that can be healthy. That's the biology. The blue jagged line that looks sporadic, that is from a weather station, high temperature for the day. The red jagged line is the soil temperature from the day from that weather station in southeast Iowa on a farmer's weather station. The takeaway here on the respiration stuff is it changes and it's very related to the weather. And what I see is when the temperature goes down, biological activity goes up. And then when it gets hot and dry, biological activity goes down. Meaning microbes like that wet, kind of cool environment is what we're showing here. The difference in the treatments is that at the beginning part of the year where we have tilled fields, that's a red line, tilled, black dirt, those fields are warming up, those microbes are becoming active, they're have good conditions, so those microbes are kicking back into shape early, where a lot of the no-till fields also have cover crops on them. So the microbes in those fields aren't coming back quite as quickly, but we see a switch then once it does start to get hot and dry. Now our fields that have cover on them, the microbes are responding positively. Those microbes are staying in better conditions versus the fields that don't have cover that end up burning up. So that's what we're showing there, but we don't need to get into it too much. 1 year of data, learning a lot on this. When we average these out, there's actually no difference in biological activity between the two, but obviously we know that tillage is doing some things to our microbes as well. According to this, maybe not quite as bad as what we might have thought, but it depends on the time of the year and it depends on the weather. Our weather this year, we were a little bit dry, for sure. We weren't down far enough south where it was really dry, but we were a little bit dry. Okay, so we've learned that we definitely can improve soil health. We know this, but we can improve it pretty quick. So some of the takeaways this year, so in that graph I was looking at tillage versus no-till, whole group stuff together, multiple soil types, all this, just getting started, so the data set is not huge. I'm also able to break apart areas with manure versus no manure, and what we found there was biological activity raises by 11% where we have manure, which we figured. Now we've got some data behind that. 11% increase, okay, pretty good. The cover crops were able to improve our biological activity by 5%. Not a lot, but I've got some fields where so I've got guys that's anywhere from first year cover crop to almost 20 years cover crop in this. So even guys in first year cover crop though, we can see biological improvements. So that's why I like using this test too, that some of this soil health stuff, it can take some time to really reap the benefits. But by analyzing it with some data, we're seeing some changes right away. 1 year, even with fairly small cover crops, almost all the cover crops in this data is cereal rye. Just about all of it. So I went over, we're trying to optimize nutrient availability. Here's corn uptake. We understand that. We understand when corn uses nitrogen, when it uses it in its peak. A lot of times we're applying nutrients in the fall or early spring. How do we analyze and optimize when those nutrients are going to be readily available though? Because not all of them are necessarily going to be available at the beginning, especially if we have manure and whatnot. So that's why we're analyzing to see how do we get them available at the right time, which really is July, August, June, of course, for sure as well. Looking at different management practices like cover crops, tying up those nutrients. When does it release? That's a big piece that we're looking at this year. I got a little bit of data on that. We're looking at new products as well. How does a stabilizer affect nutrient availability? How does a different fertilizer product, one mix versus another, starter versus other nutrient applications? So we're doing some looking at those, tying it all to weather, and doing a lot of analyzing the soil biology as well. Okay, so wanted to show, this is some of my data from all year round. And this is one of my fields. It's a cover crop versus no cover crop, side by side. All at each point, it's one sample here, one sample here. That's it. On the far left here, this May would be May of 2016. May of 2016, we had corn out there. Actually, I think I've got, is it going to work? No, maybe not. Okay, so May, we had corn out there. This is our first year of cover crops. Planted corn, had some issues. We learned. This is also looking at total nitrogen from the Haney test. So this is nitrate, ammonium, and water extractable organic nitrogen. Okay, so all nitrogen put together, everything that the plant is seeing is represented by this graph. I guess I've got a pointer here, don't I? So corn harvested here in September. I've got a little bit more data on this. I guess I'm going to split it out. But what we're trying to do overall with this is we're analyzing how does nitrogen availability change all year round. How do we hold on to it until we really need it? So January right here, so that'd be January of 2017. This is the 2017 growing season, is the bulk of this data. And it was soybeans. Okay, that's why throughout most of that year, it's fairly kind of flat, not a whole lot going on. We obviously didn't fertilize our soybeans with nitrogen. An interesting takeaway was December, so winter of 2016, right here, we've got an increase. That's from mineralization happening over the winter. Then we've got the season going on, soybeans out there. We do see an increase, of course, in nitrogen availability. They're producing their own. I think we're also getting a release from the cover crop out there as well. We're getting a release from the corn residue as well. So we need to really hone in on that, especially for the corn. For the soybeans, not as big of a deal. The spike here at the end, like December, we had our fall anhydrous went on there. I'd like to get away from anhydrous, of course. Definitely not good on soil health, on soil biology. I mean, we know what anhydrous does to our cells, and microbes are made out of the same thing that we are. So anhydrous is definitely not good. We did add in a additive that's supposed to alleviate some of the impact on biology, but so we're trying using anhydrous because it's really cheap. So we're kind of in a strip till situation with our corn. So we'll go back and we'll strip right over those anhydrous knives. So this fall, after we harvested the beans, we drilled back in rye again. 35-pound cereal rye leading up to corn next year. Okay, so that was a lot of stuff. This is a little piece of that. And instead of looking at total nitrogen, this is just nitrate and ammonium, mostly nitrate. And what I did, this is 2016 right here. So coming off of corn, okay, so this is corn using that nitrogen. And in August, we have less than 10 pounds of nitrate and ammonium sitting out there. We use that stuff up pretty well. Under the no-till, we produced 265 bushel corn right here. Under the cover crop, we had a lot of logistical issues. Raised 245. We lost 20 bushel, but even 245 bushel corn was still the best corn we'd ever pulled from here. But it was a 20 bushel loss side by side. A lot of logistical issues. We got corn going back out there next year, planting into cover crop, and we'll see if we can make up for that. Okay, so this I think is a big tool to take to the water quality kind of people of the importance of cover crops. And we see that, but a lot of the data we see is in the spring. So what's going on over the winter? Okay, so we harvested our corn in September. It was kind of an early season corn. Harvested in September, like I said, really good yields. September, actually I think I got a dealie on it. September, we harvested and we had our highest biological activity from the Sylvita CO2 respiration, which is part of the Haney test, okay? So what I think happened is we had really good weather conditions, we had moisture, we had great temperature, and we had a lot of fresh corn residue. So those microbes were super happy. In September, they were going nuts. I come back a month later, those were all taken on the 15th of the month. Come back on October 15th, we've got all this inorganic nitrogen that mineralized, and it's sitting out there. Going to beans next year, we haven't applied any nutrients out here since early spring. And now we've got this big flush of nitrogen in October, right when we really don't need it. Luckily, we planted our cover crop right at the end of September, and now this red line, that's our cover crop holding all that nitrogen. The blue line goes down here. We had all this mineralization. It goes down. I think we're losing a little bit to some rainfall in there. This is also only a 6-inch test. So when I say losing it, we're not necessarily losing all of it. It's going straight out the tile and it's gone. It's not in the top 6 inches anymore. It's working its way down, down, down. Eventually we might be losing it if we don't get it pulled back up fast enough. I think I lost oh, there we go. Okay, so this blue line now, over the winter, we had so this was winter 2016, 2017. We had a lot of warming and cooling and kind of a oddly warm winter. We had a lot of mineralization going on out here. I don't know if my pointer's working. We had a lot of mineralization going on out there. That way, in February, I had 35 pounds sitting out there available, not going to be used for months. 35 pounds sitting out there, where I had the cover crop, I only had 5 pounds sitting out there. And as you can see, that rain turns back on then, and by the time we come around to plant in April, it's all gone. So this has been interesting to see. So mineralization there, where at the cover crop, we're holding on to that stuff. So this has been really eye-opening. I'm pulling samples out here again at the same time and pulling on a couple other fields too. So we've got a lot more data coming on this as well. But so that's a big takeaway on being able to use cover crops. But so we can see there that the cover crop is holding on to our nutrients, which is good. That's what we want. That's one of the definite benefits of cover crops. The question is, how much is being tied up in there, and when do I get it back? So helping farmers to adjust nitrogen timing, fall versus spring pre-plant versus what's going on with your planter, side dress, wide drop, whatever your program is. This keeps jumping. So whatever your program is, we need to figure out when are your nutrients coming available, and how can we optimize timing to get what we need when we need it. That's what we're looking at here. Okay, so this is my full data set again, Southeast Iowa only. Green line is with cover crops, about 60 samples at each point, and this is the average. The red line is all the fields with no cover crop, so there's about 40 points per date there. The takeaway here is April 1st, we're not going to plant corn at least till April 15th. April 1st, I have 80 pounds of mostly nitrate sitting out there, 80 pounds, wherewith I've got the cover crop, I only have 35 pounds. We had an extra 45 pounds of nitrate sitting out there at April 1st. And you can see we had a pretty wet beginning of April, and I think we lost a lot of it. Where with the cover crop, I'm holding that stuff. A lot of guys, our cover crop is still growing through here. I've got plenty of guys who are fairly aggressive at letting that stuff keep going. We're holding on to it. And now it's, okay, when are we releasing some of it back up? Looks like maybe 5 weeks kind of a time frame. This year we're going to be pulling soil samples once a week, looking at this stuff. Pulling soil samples once a week, doing crop tissue doing rye tissue samples, rye dry matter samples, soil samples to look at when are those nutrients coming in the soil, and corn tissue samples to see when is it going into the plant, and figure out how to optimize this stuff. The reason we have a little bit of a dip there right here where it goes down. We had some rain there. Why does it not really show up over here? I don't know. We would have had some side dress in there as well. Maybe that compensated for it. A couple things there. 1 year worth of stuff. We'll get a lot more going next year. So overall here, it's how much is tied up by that cover crop? When do we get it back? So I think that ties into a lot of our operations. That how do we use that cover crop for a major tool for more than just for erosion control? Utilizing it as a stabilizer. Okay, but we can have some issues with our cover crop as well. This year, 2017, we didn't really see a whole lot of carbon penalty issues, but 2016 we did. So especially if you're new to cover crops, you really want to watch it. I encourage my guys to not get super aggressive at the beginning when you're getting into it. That rye, especially if you're using cereal rye, it's scavenging nutrients. It's pulling them out of the soil where it's not going to be available to your corn, which is okay, but we just need to adjust for that. So depending on how big your rye is and how thick you've got it out there, you're tying up a lot of nutrients. You're also adding a lot of carbon to the soil. With our testing, we're looking at carbon and nitrogen ratio and trying to keep that in balance. What I found, this was 2016. Like I said, 2017, we really didn't have the issue for weather reasons. What I found was that guys with the carbon penalty, our farm was one of them. It's our first year doing it, messed up a lot of things. Guys with the carbon penalty at V1 had an average C to N ratio of 70 to 1. We want it to be below 20 to 1. That says greater than 20. It should be less than 21. I apologize. The guys who have been doing this stuff for a long time, I work with like Steve Berger, Rob Stout, some of these guys who have been doing it for a long time. They, at the same time, average a C to N ratio of 12 to 1 and didn't have the issues. Like I said, on my farm, we had this poor C to N ratio. We ended up losing 20 bushel the acre because we were losing girth on our ears. We were losing those ovules at the beginning because if we're stressing that crop at the early part of the year going into determining kernels, if we screw that up, we can lose yield quick. So we've got to figure out how do we get corn, how do we make sure our corn is happy at all times? So we've got to make sure that we can watch the C to N ratio, keep it in balance. And if it's not, we need to fix it at least in a small area. That's why I do encourage guys to put on nutrients with the planter. So you can fix your C to N ratio in that small area, not a big deal. Let the biology do its thing in between the rows. As your roots grow and need more area, now we've given the soil time to be fixed and to balance itself back out. So on these areas, like I said, this data was at V1. I came back about V5, and none of the fields had a poor C to N ratio. Okay, it balances out. The soil looks for balance. That's why I keep saying soil health is balance. But Tim's got a question. Yeah. Okay, so this carbon to nitrogen ratio is a value given straight from the Haney test. And what he's looking at is this is water extractable carbon and water extractable nitrogen. Okay, so that's the readily available carbon, readily available nitrogen. It's most representative of what the microbes are seeing. So carbon, we've talked a lot about carbon here in this conference too. Carbon is obviously a good thing. But it was brought up too that when you have carbon, you need to balance that out with more nitrogen too. They're going to stabilize, they're going to find balance in your soil. They need to grow together. So as we're feeding our microbes more, we're giving them more carbon out there. We need to make sure that we have the nitrogen available as well. So kind of fertilizing the rye, but also if we keep it smaller, we don't have near as much carbon to deal with. So if you're newer to cover crops, ease into it, take your time. If it's when it gets away from you, and that's when we have some of these issues. So from that test, or from the test, all it is carbon divided by nitrogen. There's your score. So we want to grow both of them together. And organic carbon is a piece of the organic matter. So why Haney doesn't use the organic matter in his test is because organic matter, his analogy is organic matter is the house. Organic matter is the house for the microbes. We can hold a lot of nutrients there. we've got a lot of surface area for microbes to live on, for water holding capacity. It's the house. The organic carbon is the refrigerator. It's the food in the house. You can have a big house, but not a lot of food because it's been depleted. Or you can have a house that's fine, but it's got a lot of food. And that's what your microbes are after. So that's what we're able to look at here. So we're trying to build carbon and nitrogen together. That's why I like the diverse cover crop mixes and stuff. We're trying that a little bit now too, and trying to build carbon and nitrogen together. That kind of get what you're getting at, Tim? Okay. So now what stuff are we working on going forward? So we see that we need to continuously build this stuff up. We need to build soil health, but we need to do it in a way that logistically works out and is beneficial for the bottom line. So I think it's collaborating together. That's why I like PFI. I think it's a good group to be able to work together, try things out. One person's not going to be able to go and figure out all of these issues just on their one farm. But if we have a whole bunch of, hundreds of people doing a tiny little piece, now we can learn together quick. Networking, sharing ideas. We're doing a lot of stuff on social media. So check us out there, but sharing ideas, documenting the process, not only showing, hey, look at this awesome stuff, look how great we can be if you do soil health, look how awesome this is, but how do I get there? I've got conventional tillage guys who are planting cover crops. So in a conventional tillage system, how do we work into this? And how do we make baby steps that encourage a positive economic benefit? Okay, so some of our applications today on how do we utilize some of this stuff. Evaluating your current soil health. There's a lot of tools to be able to do this. The Haney test is one of them. There's multiple others as well. Dr. Franz Lubers talks about some of the testing he's done. I sent samples to like 10 different labs this year. There's a lot of different things you can do. It depends on what exactly you want to look at. If you want to look at optimizing nutrient utilization, that's where I think the Haney test can help. That's why I've done that. Sampling, okay, so how we're going to use this year on some of my farmers' fields is we're going to sample about 2 weeks before application because we got to take the samples. The lab takes a while to get it back. We got to analyze that data and make a decision. We're going to pull samples 2 weeks before an application, see where are we at, especially like where I have the lines of nutrient availability. We know where we were last year. We know where it's normal, especially for Southeast Iowa. I'm building a lot of data for all around the rest of the Corn Belt. But we understand where we were before. Now we can split our application full rate versus half rate for one round. No big deal. It doesn't have to be a full-blown plot, but let's try some things out. Let's turn off the side dress for a little while, or let's double the rate of side dress for one round, or of starter, or whatever we want. See what works better. So now we can look going forward, okay, where was I in 2018? What worked well? 2019, where am I sitting? Am I lower than I was in 2018? Okay, we need to make sure we tack on a little bit extra to make sure that we're meeting our yield goals. Soon, we're going to be able to, instead of sending samples to the lab to see where's my nitrogen at today, where's my biology at today, there's sensors coming to be able to do this in real time in your field. Real-time CO2 monitors and real-time nitrogen monitors as well. The picture here is from Haney's lab. I was just down in Texas this week with Dr. Haney, and this is his CO2 sensor. It's looking at CO2 emitted in real time, and we're able to get really accurate readings of biological activity in the soil and tie that into an overall score. The thing is, for me, it's okay, good soil health, good biological activity, okay, awesome, we get it. Mycorrhiza, great. How do we use that? Because we have good mycorrhiza, how much can I reduce my phosphorus applications by? Because I have good nitrogen cycling, how much can I reduce my nitrogen load by? That's what we're looking at. And these tools are going to be able to help us get there. So Dr. Haney sent me a couple of them. They're really sweet. So all it is these sensors are on a mason jar, using near infrared to monitor CO2 in real time. Because like I said, microbes are breathing CO2 just like we do, so we can collect that in an airtight jar and we can track it in real time. This is a demo I did just a week ago. What we're looking at here, the top line that's going up, you can see that's from my 3rd-year cover crop. That's from the exact spot that I was showing the data from all year round, and the split over the winter. That's this exact same trial. I sample there all the time. So what happened on the left here, that's at the very beginning. There's no soil in the jar. We dry these soils down. You have to weigh it out. You put in a set amount of water. You start dry with them in the jar, wet them, and you lock it up. And this data is pulling every 3 seconds and plotting it on here. And what we're able to see is where we've got cover crop, those microbes just come back alive like crazy. So this is like 1 hour, or maybe 2 hours from left to right. And those cover crop microbes are happy. And this sample was pulled in January, but they warm back up, they come alive, and they're loving it. Right next to it, it's still no-till. It's still a really great field. This is Mahaska soil type, 94 CSR. This is awesome stuff. 40 foot over, those microbes are coming alive, but not near like they are under the cover crop. I was at a conference deal doing this, and a farmer came up. I'm like, hey, watch this. I took the lid off of my jar and let it go back down to the room, which took like 30 seconds, and then I blew on it. And you can look at our own CO2 and stuff as well. So that's just showing how responsive these tools are. But the thing with this, okay, now under my cover crop, I've got good biology. Awesome. How do we use that? And where I think we can use that is areas with good biology. We're going to be able to break that cover crop down quicker. We can avoid some of our issues, and we can move soil health forward faster. Overall, just trying to be kind of a catalyst here and driving this soil health movement by documenting where are we learning, what can we do, who's figuring stuff out, what are the hiccups in the road, how do we overcome them, how do we help other people to avoid some of those issues. So people who are experienced have gone through issues 1 through 40, there's a lot of them. Now they're working on some of the bigger issues. How do we help these other guys who are still on issue number 1? And we can help them overcome all that quick. So we're documenting that, we're getting some data behind it, and we're able to learn. Looking at products and management practices to help us get there. Documenting each of these baby steps along the way, and like I said, using that data to show we're making some progress. So kind of buzzed through that pretty quick, but wanted to see your thoughts, questions. I know I went through it fast, so didn't have a lot of interjecting throughout, but we can go back and we can look at some other stuff as well. How many other people, I guess, have seen the Haney test being done or need more explanation on that as well? All of these Haney tests, the data here was all from Brookside Labs. Currently, Dr. Haney supports the test being done at Brookside and at Ward Labs. And then he's running it in his own lab, of course, as well. So now we're looking at, instead of, it's getting some data behind this soil health movement. It's analyzing the pieces, and this test looks at like 35 different parameters. Where can we improve first? What's our limiting factor? And we can work on that, solve that issue, then we go on to the next one. Which for right now, it's been, how do we get biology going? How do we optimize nitrogen? Because that can return a direct money back in our pockets. Yeah, so I've done some in a fence line. So I did fence line versus right inside the field. The big takeaway was the organic carbon that we talked about. So in the fence line, my organic carbon level was at like 350 parts per million just inside in the field, which 350 was the highest one I'd ever seen. 350 in the fence line. In the field, I was only at 250, which would be average. So that's a big takeaway, that we've burned up a lot of that organic carbon that was from that undisturbed fence line, where in the field, we don't have that. It's a corn soybean rotation, didn't have manure on that one. We are able to build up our organic carbon, but we've got to really feed that. And we've got to feed our organic nitrogen along the way. So that's why it's important to analyze the manure that you're putting out there, understand the cover crop mixes that you're putting out there, understand how tall it's getting as far as how much carbon you're putting out. But the other parameters like biological activity, it was definitely very high, but it was comparable to some of the things we can see in the field. So in that fence line, it was a monocrop, it was a brome grass fence line. So there's a lot of microbes out there, but they're only the brome grass type of microbes. In the field, we had corn microbes, soybean microbes, cover crop microbes, manure microbes. There's microbes that like our fertilizers and stuff as well. We're feeding those guys. In the field, we've got a little bit more, not a lot of diversity, but compared to a monoculture fence line, I think we had a little bit more diversity. So we can get that biology going even more by feeding it a variety of things, because different microbes eat different things. So with those sensors, what we're going to be able to do now is take your soil, put it in 2 different jars, just split a sample, put it in 2 jars, especially like biologicals. Put one biological product in one jar, a different biological product in another jar, and see how your soils react. Whichever biological is reacting with your native biologicals, well, there you go. That's one you can use. Or one stabilizer versus another, or one chemical versus another, and we can watch that in real time. And it's going to be awesome. Those sensors, so he's developing ones that you put in the field, but they're not available yet. These ones he doesn't have them in full production or nothing yet. So there's only a couple of them out. So right now we've got to take the soil and take it back to the office and test it. This year I'm going to be taking a lot of soil samples in the field. We'll have multiple thousand Haney tests this year, taken multiple times throughout the year, like we said. And then I'm going to take some of that soil back to my office and dry it down, and then do the CO2 test on it to see, get us some data that way and analyze, especially because I've got a lot of side-by-side trials. So we're going to collect some data right there quickly, and I'm also trying to understand how do those biological functions change in the time between the time I pull the sample and it gets analyzed at the lab, because there's got to be stuff happening there. So I'm going to look at it. And then with those soils, we'll look at the CO2, then we'll wet it more, and we can look at nitrate in real time as well. Iowa State has nitrate sensors that they're developing, Mike Castellano and his group. So I'm getting some of those to test out. And these nitrate sensors look at nitrate in real time. It sends it to your phone. They've developed an app and everything for it. And their main objective is to look at tile water. So now we don't have to sample our tile water anymore and send it to a lab. We can literally do it right there with a cheap sensor and do it all the time. Do it over and over as much as we want. So with our soils, where this stuff is going is that as a farmer, I know I'm going to plant corn, or I'm going to side dress, or I'm going to make a nutrient application. I can go out to my field that day, take a soil sample, bring it back into my house, analyze the CO2, analyze the biological activity. You do that first because you don't saturate the soils or nothing. You put in a small amount of water in that, just a couple milliliters of water for 40 grams. And we'll be able to look at the biological activity of that field. Then we'll be able to look at the nitrate concentration of that field and then go make your nutrient application adjusted based on those findings. So you don't even have to send your sample to the lab anymore. Now those sensors are both coming to have out in your field all the time, and it'll send it right back to your computer, to your phone or whatever. That way you can just look at it, that you're gonna go make an application. We'll see how the sensors I've been looking at, they're not expensive at all, but not all of them are gonna be fully able to stay out in a field all the time. We'll have to be fairly smart about where we're putting them and whatnot, but so that's where this is going, to be able to analyze the biological activity, analyze the nitrate, make an application. Why I'm taking samples all the time is we need to understand what happened leading up to that point that influenced that, and what's going to happen after. How is that nitrate level going to change? what is still left to mineralize, how quickly are we using that stuff up, based on my different products, when are those going to become plant available. So doing a lot of that work fast. But so that's kind of, I think, where soil sampling and stuff, or just agronomics is going, utilizing more sensors. All of that data has got to be definitely very directly tied to weather as well. Weather's big on this stuff. Obviously, that's a huge driving force behind this, and we can see that pretty quickly with some of the data. But yeah. Analyzing hog manure. So your question is, how do you analyze hog manure? You can take samples and send them to the labs. Commercial labs will analyze that hog manure. So they have jars that you can collect that in. You can even do it in like a Gatorade bottle or whatever if you want as well. You can take that liquid hog manure. You can do compost or any other manures as well. Send it to a lab. Midwest does it. Yep. So, and then the key there would be to analyze, okay, what is my nutrient concentration, and get a better idea to tie that into my nutrient plan. So if I'm planning on putting on 180 units of nitrogen, we need to understand how much is going on with the manure and adjust the rest of our applications because of that. Some of the guys I work with, they're pulling manure samples when they're pumping their hog pits. They pull manure samples once every 2 hours. So then you're getting a good idea, because concentration changes throughout the pit. And of course, building to building, it changes a lot. You definitely want to take at least one sample per building. Yeah. Yeah. So the question was there a fall anhydrous application put on with the cover crops? So the data that I've got right now has a wide variety of things. A lot of guys are using anhydrous because it's cheap, and we've done it for a long time. My thought on that is, and why, like, we're still using it on our farm, like I said, my thought is anhydrous is obviously not good for soil health, especially in that area. I mean, it's frying stuff. But if we can balance that out with a positive, like cover crops, okay, yeah, we're seeing a dip, but okay, we're getting some of it back. Same thing with like a tillage pass. So, okay, yeah, we've got a tillage pass, it's not good, but if we've got something positive out there, maybe we can balance it out. We're gonna stay stagnant versus if I didn't have the anhydrous, I could keep going up, up, up. You know, it's gonna knock me back down as far as in my overall building soil health. But so back to the question, there'd be some that have anhydrous, some that don't. As my data set builds, we'll be able to really split out a lot of that stuff. We're doing a better job of keeping records and stuff as well to analyze which ones are anhydrous. That's what my farmers are wanting, like, okay, right now I'm able to split it between cover crop guys, no cover crop guys, tillage guys, no tillage, manure guys versus no manure. Analyze those data sets separately. How do I compare to someone who's similar to me? We need to break that down even more and more to soil type, even more on your management practices, down to really minute differences, but that's a lot of data. So we're getting there. Yeah. Oh, that's okay. Yep. Right. Yeah. 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 So I think I think we're driving it a little bit, or we're gonna end up like Ohio or like the Lake Erie Basin, where you don't get to put on anything in the fall at all. And then so their regulations there, Lake Erie Basin, is no fall applications, and in the spring you can only apply manure or nutrients when there's no rain in the forecast. How many days in the spring in Iowa is there no rain in the forecast? So that's an issue. So we want to make sure we avoid, but I agree with you that we need to be a lot smarter with those applications. Get them, if we apply in the fall, how do we hold that with a cover crop or with better biology? Keep it there. There's a lot of new stabilizers coming out too that we're doing some testing with. And there's another new one that I know coming out this fall that we're going to be trying out. So maybe that's a way to find some balance. How do we keep that stuff out there? But I am doing quite a bit of testing on anhydrous areas too to see when is that coming available and how is it changing from ammonium to nitrate. That's very interesting as well. So with this test, we're able to see that difference. So that's been cool. But yeah, I agree. We need to keep moving to better application methods. And like I said, definitely in the spring, because we're not using a lot till June, July, August. So there's a lot of opportunity for more products to come that can give us better options. So more technology to put it on with the planter or mix it in with a herbicide application or maybe a liquid application on its own, side dressing. So, but like I said, it's the convenience part of the fall. So how do we logistically overcome some of those issues for spring applications, being smarter about it, understanding our soils better, building our soils so it's not muddy in the spring, not as muddy in the spring. Now that gives us some options. But yeah, Theo. Yeah. So the question's on depth based on different soil types and how are we analyzing that. So yeah, this test is a 6-inch test. I'm doing a little bit of 12-inch nitrate test, but not a lot. And the reason he's got it for a 6-inch test is that's where a lot of the biological activity is going on, of course. You can look lower, but obviously the biological activity decreases a lot, and it would be very different. It'd be the anaerobic bacteria down there that aren't breathing the oxygen, where you've got the guys breathing oxygen up here. We also have the bulk of our roots are up in the 6 inches. I think there is some things to look at, though, like you're saying, Theo, on how are those nutrients deeper coming available? How do we get them pulled back up into the top 6 inches? There's some tests to look at that. I know Ken Ferry likes the ISNT over in Illinois. I think that's 4 feet, 4 foot deep test to look at nitrogen. So there's some things to look at going forward. I pulling really deep samples like that by hand is not very fun. So there's a lot of room for some sensors and stuff to be able to help us out there, though, or just to do the work on specific soil types, get an understanding of them, and then deploy it out across other similar soils. That's a way to maybe do it logistically. But yeah. Mm-hmm. Yeah. So the question's on what about some correlations between this soil health test versus a plant tissue test or a sap test. So I have been pulling some plant tissue tests along with these. I pull all this stuff on the same day. Don't have a lot of really good stuff to directly answer your question at this point. I haven't done any sap analysis yet either, but these nitrate tests that I was talking about that Iowa State has, like I said, being able to use it in the water, being able to mix your soil in solution to be able to do a soil test. They're also able to do a stock test as well. Kind of a sap type of a deal, but it's more just for nitrate and it's for a growing stock. And this tool has 2 little pins on it, kind of like little computer pins or whatever, that stick into the stalk as it's growing, and you can monitor nitrate levels as your corn grows. And those sensors you can leave out there and just watch your nitrate, watch when it's going up into the plant, which would be really sweet to watch weather and watch when that's going up into your plant timing. But we'll have to move those around a little bit, I would think. The plant's going to react to that being in there. So we'll see. We'll be doing some testing with that this year. I could dig into my data set a little bit more, though, and give you a better real correlation on those. Haven't done it yet. We've got a lot of stuff coming, though, to be able to do that. So maybe in another couple months I'd have a good answer for you. But we should be able to, we should have some good differences. I have seen a little bit of some correlation where I'm looking at different liming products. So where we're looking at lime or like an ag calcium product is not only fixing pH, but fixing nutrient availability with lime. And with that, we have seen improvements with the Haney test to our micronutrient availability. And then we're seeing those micronutrients come more available in the plant. So there is some correlation. I just don't have a lot to speak on that yet. Yeah. Yeah. So the question's on what about some infield variability, different soil types, different biology in different areas, and there definitely is. And stuff changes a lot. I mean, I'm pulling samples all the time, and my biology changes a lot. I think it is really related to the weather, and soil type definitely plays a piece as well. How I think we use this large scale on the farm would be take a good soil type, a medium soil type, and a poor soil type, and do your sample there. It's too expensive to use on grids, I think, and even on sampling every single zone. At this point, it's just kind of expensive. But if we can do 3 different soil types, get a good understanding of those, and interpolate in between, that might be a way to be able to use this. Also gathering in a wider array of soil types, get a good understanding of those. So it's just building over time, but definitely some differences in between them. And the differences that I'm interested in looking at is different soil types are going to release nutrients differently. You know, a heavy soil type is going to be holding on to some of those nutrients, especially P and K, and it's going to release nitrogen differently. So versus one that has really high organic matter or a sandy soil, those nutrients are going to come available differently. So we're looking at that now. Like I said, on a farmer's field, we can take, if we're going to make an application in 2 weeks, like I said, we can't do the day of yet, but in a couple of years we can. We can take a sample 2 weeks ahead in different soil types, get us a good idea of what's going on in those key soil areas, and then make our application there and monitor what worked, what didn't work, and take that not only to yield, but to economics. And we can do that now. There's data management tools to do that. They're super cheap. But definitely some differences. Yeah. So the question was, what about a sugar source on the field? And if anyone's trying to, we tried it. We did it a little bit this year. It was a molasses, and we put it in with our herbicide. It didn't show up in the testing right now. It was the first year, and it was on a field that already has decent soil health. Definitely not great by any means, but it's fine. And what we saw, like I said, was not necessarily in the data, but where we had the sugar applied with our round, it was when we were killing off our rye cover crop, mixed in with our Roundup, and where we had the sugar, the cover crop did not die as fast. It stayed a little bit greener. It didn't get fried right away. Where we didn't have the molasses, that stuff was fried and dead and brown. So to me, that is, okay, we're feeding at the same time that we're killing, so maybe that's not only happening to the rye, but also to the microbes. So that's where I think we can, offset a little bit. That Roundup is obviously not good for soil health either, but maybe we can offset that with a sugar type of product. You gotta watch the deer though with those things too. They smell it and then they come up. But I don't know if we're going to test that product this year again, just because the results, like for our operation, wasn't very staggering or nothing. But there's more stuff coming. Yeah. The rate of molasses? I don't remember what it was. It was super cheap though, because because it's a byproduct. So the stuff we got was from a company over there in the Quad Cities, I believe, and it's a byproduct. So they were like, give it to you. We had a 2,000 gallon tank of the stuff, and yeah, it was like less than $1 an acre to put the stuff on. But I forget what exactly the rate was, but it would have went on multiple times throughout the year. But yeah, it was a liquid. So as far as the molasses going through the sprayer, we didn't have any issues with it. It's fairly kind of diluted down, and it's a product that they've have it formulated for that purpose of going through a sprayer. So we didn't end up changing the screens or nothing, and it worked fine. There definitely can be some horror stories, but for that particular product, we were fine. Yeah. Yeah. So that's what we would like to see is the microbes going more. I think we were maybe getting some. I mean, we could see that with how it reacted with the rye. I think with the Solvita test right now, why Haney is using this infrared sensor instead of Solvita is that the Solvita test is really good for not that great of biological activity, but when you get to higher biological activity, you can't tell the differences quite as much. So the Solvita test, they analyze that by putting your soil in a jar with a little color changing paddle in it, and you can't see the difference in the colors. The human eye can't see it. That's why they have the reader deal to be able to monitor that. And at those high levels of biological activity, difference between like green and a little bit more green and a little bit more green is really tough. So we might be able to see a little bit better with our infrared sensors now, especially if we take that soil back to the office and put it in jars side by side and look. That would be awesome. Need to make a video about that. So I think there's some potential with it, especially because if you can get it cheap and as a byproduct, there's some potential with it. But we only looked at it 1 year and then one side by side. But yeah, a lot more stuff coming. I don't need to keep everyone here. I know it's time. Yeah, but if you guys have more questions, I mean, I'll stick around and answer questions. We'll have a lot more stuff going, like on Twitter and Facebook too, so you can check out a lot of the things we're working on there as well. And yeah, thanks for your input though.
Let's thank Mitchell for coming.